Imagine looking up at the night sky and knowing that somewhere out there, a planet exists that is even better suited for life than Earth. What if we discovered such a place, a true Earth 2.0, where conditions were so perfect that humanity could not only survive but thrive beyond our wildest dreams? Scientists have long been searching for exoplanets, planets beyond our solar system, that could potentially support life. But finding a habitable planet is only the beginning. Would we ever be able to reach it? Could we colonize it? And most importantly, what would it mean for the future of our species? Scientists aren't just looking for Earth-like planets, they are searching for worlds that might be even better than our own. A superhabitable planet would have conditions that make life easier, with a stable climate, abundant water, and a long-lasting star. The ideal candidate would be slightly larger than Earth, have a stronger magnetic field to protect against cosmic radiation, and orbit a stable K-type dwarf star, which burns cooler and lasts longer than our Sun. These factors could create a world where life not only survives but flourishes. Spotting an exoplanet is incredibly difficult because these distant worlds do not shine on their own, they only reflect light from their stars. Most exoplanets are found using the transit method, where telescopes like NASA's Kepler and TESS transiting exoplanet survey satellite measure tiny dips in a star's brightness as a planet crosses in front of it. This method has helped scientists confirm thousands of exoplanets, some of which could be potential candidates for Earth 2.0. One of the most exciting candidates is Kepler 1649c, located 300 light-years away. This planet orbits a red dwarf star, receives 75% of the sunlight that Earth does, and might have liquid water. However, it also has challenges such as potential tidal locking, where one side of the planet always faces its star, creating extreme temperature differences. Even if we found the perfect planet, reaching it would be a monumental challenge. With our current rocket technology, it would take tens of thousands of years to reach even the closest exoplanet. Scientists are working on new propulsion technologies, such as nuclear fusion, antimatter propulsion, and even theoretical concepts like the Alcubierre warp drive, which could bend spacetime to allow faster-than-light travel. If we do find Earth 2.0, should we colonize it? What if life already exists there? Humanity has a long history of exploring and settling new lands, often at the expense of indigenous populations. If an exoplanet harbors primitive life, do we have the right to interfere? These are the ethical questions that future generations may have to answer. While finding a habitable exoplanet is exciting, we might not need to look so far. Moons like Titan, Saturn's largest moon, have thick atmospheres and abundant resources, making them possible future homes for humans. Instead of spending thousands of years traveling to an exoplanet, could we build sustainable colonies on these closer celestial bodies? The search for Earth 2.0 is not just about finding another planet, it's about understanding our place in the universe. Whether we discover a perfect new home or learn how to better care for our own, this journey will shape the future of humanity. Perhaps one day, future generations will gaze up at the night sky, knowing that a second Earth is not just a dream but a reality waiting to be explored. This is just the beginning of our exploration into the possibilities of Earth 2.0. As scientists continue to discover new exoplanets and develop advanced technologies, the dream of finding a second home for humanity becomes more tangible. With future innovations in space travel, artificial intelligence, and planetary engineering, we may one day overcome the vast distances of the cosmos and establish a thriving presence beyond our solar system. Imagine a future where humanity is not confined to Earth but spreads across the galaxy, adapting to new environments and evolving in ways we can scarcely predict. Will we become a multi-planetary species, or will we discover that our true destiny lies in preserving and enhancing our home planet? These questions drive the ongoing quest for knowledge and exploration, pushing the boundaries of what we once thought possible. As we continue to explore the vastness of space, we must also confront the moral and philosophical implications of such discoveries. The search for Earth 2.0 challenges us to think about our responsibilities as a species, not just to our planet, but to the universe itself. Whether we find a paradise waiting for us or an empty world in need of transformation, our journey into the stars is only just beginning.